Today I want to take a look at this simplifying rational expression scenario. On the surface, this looks like pretty straightforward problems, but I want to talk about the common errors that happen on these two scenarios. Now the first one, we have 2x plus 5 divided by 5 plus 2x, and the second one, we have x minus 6 divided by 6 minus x. Look very similar, but the big difference here is the operation that's happening between the two terms. We have 2x plus 5, 5 plus 2x, x minus 6, 6 minus x. Now, in this first scenario, 2x plus 5 over 5 plus 2x, this is going to simplify down to 1. And here's why. 2x plus 5 and 5 plus 2x is the same thing. I could rewrite both of those terms. So I could rewrite 2x plus 5 as 5 plus 2x, and I could leave 5 plus 2x as is. And I could do the other way. I can rewrite this as 2x plus 5 over 2x plus 5. They're interchangeable. I can rearrange the terms when it's addition like this because it doesn't change anything. Positive 5, positive 5. Positive 2x, positive 2x. I could rearrange the terms, and at the end of the day, that's going to simplify down to 1 because I have a 5 plus 2x divided by 5 plus 2x. That's just 1. Now, I'm not doing this, though. I'm not doing this. I'm not doing 2x plus 5 over 2x plus 5 and then saying, well, I have a 2x and a 2x, I have a 5 and a 5. I'm not doing that. That's not accurate to say. I'm looking at it as 2x plus 5 divided by 2x plus 5. That is 1. The same way as if you had like 3 divided by 3. 3 divided by 3 is 1. And the reason this kind of works is because if I set x equal to some value, let's say I say x is equal to 2. What I'm then doing is I'm saying 2 times 2 plus 5 over 2 times 2 plus 5 is going to give us the same answer. 2 times 2 is 4, 4 plus 5 is 9, same thing on the bottom, 4 plus 5 is 9, 9 over 9 is 1. So you're not looking at it as 2x over 2x and 5 over 5. You're looking at 2x plus 5 representing a singular number. So it's just representing something. When x is equal to some value, that expression becomes something else, whatever that x is equal to. Now in number 11 here, the second problem I have x minus 6 over 6 minus x. What's happening here is this is not simplifying to 1. Because if I rearrange the terms, look what happens. If I rewrite this as negative 6 plus x, I'm not getting the same thing. On the bottom, I have 6 minus x. On the top, my 6 is negative. On the bottom, my 6 is positive. On the top, my x is positive 1. On the bottom, my x is negative 1. Not the same thing. So here's how we want to simplify this down. Because I'm noticing, well, I could rewrite this as x minus 6 over x minus 6 somehow. But I can't just directly rewrite that because, again, this is negative x. And if I wrote it over here, that'd be positive 1x. So I can't just rearrange it like that. I can do something, though. Here's what I want to do. I want to take out a negative 1 from the bottom. I want to factor out a negative 1. And what's going to happen then, let me erase this work over here. What's going to happen then is I'm going to have x minus 6 over negative 1 times, and then what happens from here? Well, if I take out a negative 1, this becomes negative 6. 6 becomes negative. Negative x becomes positive x. I can rewrite this one more time. X minus 6 over negative 1 times x minus 6. Now I could rearrange the terms because I took out that negative 1. And it's negative 6 plus x, positive x, negative 6, negative 6. So I am now able to rearrange it, and I get the same factor of x minus 6 on top and bottom, then simplifying that to negative 1. So that process again, I took out a negative 1 from here. I then got the same terms top and bottom, x minus 6 and x minus 6. Those just cancel down to 1. But I took out that negative 1, so I'm just going to have negative 1. 1 over negative 1 or negative 1. It doesn't matter. The whole fraction is negative. So I'm just going to leave it as negative 1. And there it is. And so the difference is here. This answer for the first one is positive 1 because it's the same thing. 2x plus 5, 5 plus 2x, same exact terms. Where on the second one, they're opposites of one another. Positive x, negative 1x. Negative 6, positive 6. So we have to take out a negative there. So we get negative 1. Common errors on that one. I can't tell you the number of times I've looked at these problems and seen this. Like we positive 1. I can't tell you the number of times that's happened because they see like, oh, I could just rearrange it and make the sign whatever I want it to make. Not exactly true. So hopefully you don't make that same mistake.